So a lot of the problems that we'll be doing will actually be multiplying very large matrices together. So for example, here, these are 6-dimensional matrices. They're 6 by 6 matrices. And so this is essentially 36 different computations you have to do to fill up this resulting 6 by 6 matrix. That takes a long time, right? And so we're going to use a mathematical trick quite regularly that will really make your life easier. And this trick is called blocked matrix multiplication. What this says is that if you have matrix, if you have zeros, okay, in square blocks along the diagonal, all the other elements will be zero. So the easiest way is just to show you this. So, I'm showing you the answer. You could go through this, right, the long way. And so how would you get this 4 here in position 1? Well, you go row by column, right? So you have the vector 1, 0, 0, 0, 0, 0, 0, dotted with column 4, 2, 0, 0, 0, 0. Well, that's going to equal 4 because you have 1 times 4 and then plus 0 times 2 plus 0 times 0 plus 0 times 0, etc. Right? All zeros, except for the first 1 times 4. It gave you the 4. So how does this trick work? Basically, what you do is you just look along the diagonal and you look for square matrices that are not 0, okay? So if you look at this matrix right here, you can see in both cases, this matrix and this matrix, there's a lot of zeros, right? And so what I've done is I've highlighted the squares that are square matrices that are common in both of these, where in both cases, there's only basically, you got rid of the zeros, okay? And so you can see that because you have zeros all in here, for example, and zeros all in here, you don't have to consider these. You can just take squares. Now note there was a 0 here, right? But because I have to have, the rule tells me, the mathematical rule tells me I have to have a square matrix, I had to have that there. So, and because this set up a 2 by 2 matrix along the diagonal, I had to then have a 2 by 2 matrix here, no matter whether or not there's zeros in here or not, okay? So I'm looking along the diagonal. So that's a 2 by 2 matrix. Then I have a bunch of zeros here, so I don't have to include those. So I'm gonna have another 1 by 1 matrix, and here was a 3 by 3 matrix. What that allows you to do is, all the zeros dotted with the zeros are gonna give you zeros. So all the zeros that aren't in your square diagonal matrices, those are going to be 0, right? And so now you broke this up into 3 much simpler problems where you have this 2 by 2 matrix, 1, 0, 1, 2, multiplied by 4, 1, 2, 3, okay? That gives you 4, 1, 8, 7. And you can see that that answer appeared in your bigger matrix if you did this manually, right, the long way. And 3 times 1, those are 1 by 1 matrix, that equals just 3, right? 3 times 1 give you 3 in the bigger matrix. And then this 3 by 3 matrix times this 3 by 3 matrix gives you this 3 by 3 matrix. So that's essentially a trick that we'll be using later on once we actually start applying these things to chemical problems.